Hello, hello. What's up, everybody? It's me and Jeremiah. I'm going to tweet out that we're going live real quick. Me and Jeremiah are hanging out. We're doing a little live stream about network analysis. It's been a while since I've streamed. So I'm EJ. I do data visualization and analysis and journalism and like playing around with data. And I met Jeremiah at MBC, where we did data journalism together. And where do you work now, Jeremiah?
Now we're going to play called Cal Matters,
Nice.
which is doing journalism focused on California.
Nice. And so what's the data that we're playing around with tonight?
Okay, so we're following money tonight, EJ. Yeah, so I've been looking a lot at, I'll get my screen sharing so I can show you where this data is actually coming from. We're in an election right now in California for a state house. You know, we got, like, just like most states, a bicameral state legislature. We call them the Assembly and the Senate, and a bunch of other races like governor, AG, Secretary of State, all on the ballot this year in California. Tons of money coming in. Tons of money always comes into California because 40 million people, all that jazz. But what we want to look at is, can we figure out who's like the most connected donor, basically, tonight? And like,
what's this like 90s website that we're looking at?
Oh, dude, 2004's website.
Sorry, okay, my bad.
This website is called Cal Access. This is the.
This looks like my middle school's website when in like early 2000.
Yeah, it might have been cutting edge at that point in time. However, it has remained unchanged. And actually, this website was supposed to be replaced by the Secretary of State, and it hasn't been. It's one of these classic government technology projects. They did it. Then late last year, when they were about to go public, the Secretary of State was like, "Actually, never mind. We're gonna start all over. I want 50 million more bucks to like figure this whole thing out." So
Okay, so this is where you got your data from this 90s website?
This is where the data comes from. Well, we don't have to use this website, but like, let me just show you what kind of data we're looking
All right, I'm going to go in standing mode. That's how excited I am.
Hey, do you know any California politicians? Like,
Not only Newsom and Pelosi, I guess, counts. Is that right?
Okay, Pelosi doesn't count here because that would be FEC because she runs in Congress.
Got it.
But let's look for.
What about who was? I don't think the old mayor of Oakland did anything. I already forgot her name. She didn't make it in.
Libby Schaaf.
No, that was the new. I was thinking one before that. During yeah, I don't know either. Anyway, yeah, is Libby Schaaf running for anything?
No, not at this level.
She was the DA. She was all pretty awful. Also, I'm not a journalist, so I can say those.
Okay, so like let's look here. So my local DA is running for Attorney General. Okay, so she's going to be in here.
Okay.
Her name is Anne Marie Schubert. So yeah, this is the best that the California state government has to offer in terms of its campaign finance disclosure. You know, I will hate because like this is totally unacceptable, but also it does provide some stuff that's pretty cool. And so this is what I've been looking at. So this is like the basic information about this committee. Should I zoom in a little bit?
Oh, so this is a committee, not a candidate, or how does that work?
In this case, yeah, this is a committee. That's kind of the central noun in this kind of land because a candidate has a committee, but everything they do has to be done through this committee. So they raise money through the committee, they spend through the committee. They can give like money themselves, but it's kind of like their LLC, if you will. You know.
Okay.
Anyway, so like.
Wait, so are there committees that aren't associated with candidates though, like PACs? You know what I mean? Like,
Yeah. So we have our own version of PACs and super PACs. So
okay.
Super PACs can spend unlimited amounts as long as it's not in coordination with the candidate, and we have a similar kind of thing. We call it independent expenditures in California. So you can run a committee and can take unlimited amounts of money, spend it however you want, as long as you don't coordinate with the candidate, and that's pretty standard for American campaign finance, but obvious loophole you could drive a Fox and Jeremia.
So you've scraped this to get the data that we're going to look at?
Yeah, so I got a robot that scrapes this whole website multiple times a day. It loads in this freaking tool, which
gangster.
Awesome.
I mean, that's pretty. I mean, that's pretty sick. It scrapes it multiple times a day.
Yeah, and I use the git scraping technique. Have you like?
Yeah, man. Data set. Simon Wilson. Gang.
Exactly. I guess that dude has contributed quite a bit to my data scraping philosophy over the last 2 years. Same. So I use so my robot even runs on GitHub Action, commits to a local SQLite database, and then that gets deployed here on Dataset. If you don't know about Dataset though, what's really nice about it is it gives you this is where you get it, but this is probably a better thing to show. It gives you a tabular interface for your data that you can easily search through. It's all based on URLs, so this is what's sick, right? My robot updates this database every day, but the URL doesn't change. So I can build a query that says like, give me all the contributors, whatever, sorted by amount. That's right here.
Right.
And you can tell like that some of this is not sorted by date, and as new data came in, we might see it here.
And there's no maximum. They're just hitting, what is that, like 5 million, 50 million?
That's $5 million. So the way you determine the maximum is very specific to the race, which makes it kind of
interesting,
complicated. But the way we figure this out is we take this ID, and so we see that this is a committee called Coalition for Safe Responsible Gaming, sponsored by California Indian Tribes. This is like a classic California political committee name, at least it's a little bit descriptive. California Indian Tribes. Some of them are like.
So this is the one that you just highlighted, 1424396. Can we look at all of their contributions?
Yeah. So in this case, this committee filed all these reports, right? So like if using Dataset, I can say filing committee ID equals, and then just put that number in there. And apply. And again, like it's in my URL. Like I could take this URL and put it in Observable or whatever I want. And then you can see that these are all the different contributions made to this committee. Now,
So that's all your nodes, right? So if we're thinking about a network, like all these committees are nodes, and then like candidate committees are like another type of node that we might want to differentiate. But like these are all. So what are the edges? What are the things that connect them?
Right. So I think so I already sent you some data, right? And so the reason I did that is because it took a while to process it. We didn't want to waste stream time doing that. But I think what I was looking at actually is something a little different. Let me build the query I'm pretty sure I used. It's any committee that donates to another committee. So with individual contributor names.
So they have to file that. So they have to file a form that says, I, Committee A, just donated $50,000 to Committee B.
Right. So if this field right here, this contributor ID field has a value, that means that this is a committee that gave to this other committee.
Got it.
So now we can go figure out whatever this is, but the donor is the California Medical Association, basically the doctor's lobby. And if we use this ID over back on this website, we'll find that doctor's lobby. So that's the committee, right? And so what do? We say, I wanted every contribution where the contributor name is not blank, signifying that it is indeed a contributor. I'm going to add one thing here, which I don't need to talk about, but it's just like a data quality check to make sure I don't overcount stuff. And so this URL, 16,000 rows, these are every committee that is given to another committee. Again, remember, if you give it to a candidate, that candidate is a committee.
Mm-hmm.
So any committee that's given to another committee in my universe that I care about.
Is there, I'm going to be skipping ahead and we can probably skip it, but can you think of a way to differentiate a candidate committee versus a non-candidate committee, like in our data?
Yeah, totally. So something that powers my scraper is this Google spreadsheet that we can absolutely use. And the problem is that it's not every single committee, right? The universe of possible committees is huge. I don't want to put all that on my robot shoulders, so to speak. But what I do have is I have a tab here where we have every candidate committee. So we can get only these IDs if that ID is in this column, we know it's a candidate committee and not an issue.
Oh, okay. So, all right, got it. So we know the IDs of candidates.
We do. We know all the IDs of every candidate. You'll see in the spreadsheet we also have office and district. So we can group them by race and by candidate.
Awesome. So it sounds like it's should we start building stuff in Gephi? It seems like we have all the ingredients, right? Yeah. We have nodes and edges.
Let's try it out.
Yeah, I guess I'll share my screen just so you can see what I'm doing. Of course, I don't know if the live stream is delayed or whatever. It's probably better if you just see it in real time. So this is what you sent me, right? So we have an observable notebook that pulls from a data set instance, and we have nodes, which I'll download as a CSV, and I have edges, which I'll download as a CSV, and they went in my downloads folder, and it's named nodes and edges. Classic. It's actually named edges 6 because I do a lot of network analysis.
What was the last thing you did with Gephi?
I don't know. It might pop up. It'll tell me. It's probably for a client that I can't talk about, which it is. It has to do with flavors. I can say that.
Okay.
Sorry to be like that.
That's what it is.
So
what's this concept? I opened Gephi. So what I would be stoked to learn right now is I was following a blog post. It was make these edges and node CSVs, right?
Mm-hmm.
Import, boom. Well, I imported and I got something that was not useful for me, right? It was a bunch of black.
Yeah, you got a hairball. You got what? The classic hairball. And I got
a hairball.
But the hairball's good. The hairball is a success. So tell me what you did. You just went file, import.
Yeah, I did exactly what you're about to do. Import spreadsheet. I didn't even do this one. I did the
import spreadsheet. Okay.
So. And then it tells, helpfully is hey, which one is your nodes and which one is your edges, and that was chill.
So it's nodes and edges. Edges. Yeah, all this stuff looks good.
So you see source and target. Now, what does that mean? I was What are the timestamps mean?
Oh, if you import data with dates, I did this with the police data, right? So I imported the incident dates with real Gephi parsable time intervals, and it let me play out incidents over years, right? So you can see an officer node grow connections over time if you import a time basis to it, if that makes sense.
Okay. Wow.
It's kind of complicated. It's not totally, it wasn't totally useful, and you can't really export it in a useful way, so... So we don't have any data in our nodes, it looks like. Like it's just the ID. Like this is where I want this is where we should do the binding of our candidate info. Like I want a candidate column that's just one if it is a candidate, right?
Okay, should we build a little observable to do that?
Yeah, if you want to do that, why don't you if you are okay with like if you can do that in the background while I do this stuff, or you can share your screen and we can do that?
I think it'll be easy because I now have that file.
Because I might run into problems with this import, so I just want to get this import rolling, and then we can bind.
So tell me again what you would like in the nodes. You would like just like a...
Yeah, so one column is the ID, and I want another column to say if it is a candidate or not, right? So I can know I want to color that. I'm basically going to use this for coloring, right? So I'm going to make my candidates red and my non-candidates blue. You know what I mean? So I'm going to color them by their like is candidate column.
Got it. Okay. No problem.
Sweet. So I got my nodes. I got my edges. It looks like we got 3,646 nodes and 11,000 edges. Does that seem right to you?
Yep, probably.
Sweet. So we probably can make it look like what you got, which is a little hairball. Come on, hairball. It's probably loading.
I love this class of tool, you know, like I consider Gephi to kind of be like QGIS or GIMP or like LibreOffice. Like, wow, aren't we so fortunate that it exists, but it's freaking hard to use by default, you know?
All right, so I believe this is your data in Workspace 2, even though I started in Workspace 1. It's not a big deal. So you saw
That's what I got.
You got this hairball. So this is actually Gephi working. This is a sign of success and should be met with celebration.
All right.
Yeah. So it's so hard to use Gephi. The next part that you're missing, there's a whole bunch of shit on the screen right now. So the first thing that we're going to do is we're going to choose a layout, and I like Force Atlas 2. Like it makes the thing that people expect. And so what you're doing is you're running a layout algorithm over and over and over again. And I like back in like 2015, I remember borrowing the video team's iMac Pro so I could run Gephi overnight on some like some old data. Like it used to be really hard to do this. Now I have a fancy computer and my life's great. So I'm just going to run the layout a little bit and you'll see it begin to arrange itself into a pattern based on the edges. Are you ready? It's pretty exciting.
Yeah, I'm ready.
All right. So it just made a kind of bigger hairball.
Yeah.
Based on the defaults.
Can we give more spacing or something?
I'm glad you asked that. So right now our scaling is at 2. So let's make it fucking 20. Or 20 for now, right? Okay, so now it looks a little more like a universe that's like explorable.
Yeah, definitely. That's cool.
So maybe like 200. And now there's like, it's interesting, right? Because there's a lot of interconnectedness, but like whatever the fuck this is really interesting, right? This little like super connecting node, and it's just running over and over and over based on the parameters that we've set. So we can also do other things like we can say dissuade hubs, which sort of bounces things out a little bit. You can put it into logarithmic mode, which makes everything insane. You can prevent overlap, which makes it way slower to compute, but that's usually good for your final step when you're like labeling, right? So I'll let it run for a while and get into the rough position I like. And then I'll do prevent overlap and then like get it to a place where I can like look at it. So anyway, this has been running for like...
It's like a dynamic option. You're letting it run for a little bit, then you uncheck the box and it like stops.
I haven't stopped the simulation since we started it, right? So I've just been turning these things on and off and changing the parameters. And so now that it's in a place I like, I'm going to stop it. So now it's like frozen in time in this arrangement.
Okay, wow.
And there's a whole bunch of other layouts that you can get, right? So I can turn this into a big circle, right? This is just another type of layout that Gephi has as a way of understanding your network data.
Totally.
So
It's not that useful, but cool.
Yeah, and there's like
have you ever done that?
I've done it. Yeah, I actually used it for if you have like smaller things. That's kind of a cool animation. If you have a smaller number of things, the circle is good because your eye can actually follow across the circle to see like what's connected. I think there's a name. There's a really cool name for that kind of circle graph. But anyway, so that's layouts. So that's this like box on the left, and it just has a bunch of other cool layouts that it has a random layout, all this. But does that make sense? Like what that layout panel does?
Yeah, it does. I mean, I think I need a faster computer because yours was fast and mine was.
Yeah, I don't want to brag or nothing,
slow.
But it's.
But that's so cool. You ran this, and then we can see a little bit. I mean, I don't think I can draw on your screen or anything, but in the upper left quadrant.
Yeah, you want to know who the fuck is this? Who the fuck is? Great question. Right. Who is this, and what are they doing? Let's just look it up because that's fascinating, right? They're receiving a bunch and sending out a bunch. They're like a clearinghouse of money. It looks like. And let's do some.
How do we know if they're sending it out? How do we tell?
We don't really know, but you can sort of see that these are not. These don't have outward connections. I guess theoretically it could be sending it to a lot of candidates, but I don't think it. I don't. And these aren't candidates, right? Because they'd be getting other things into them from other committees.
It seems very unlikely that, yes, exactly.
Right, this looks like a committee that's receiving from a bunch of other smaller committees that aren't doing anything else except for donating to that committee. So let's look at what it is, and then let's run some stats on it because that'll help this graph look more useful. But I just want to indulge our curiosity. Who is this? So you can right click and then do select in data lab if it'll let me, but it won't. Gephi's being so weird. There we go. Select in data lab. So this is, are you ready for the number? It's 1437995.
Oh,
I'm sorry.
1437995.
Yeah.
Yeah, can you tell that I've memorized a bunch of these numbers? Oh, wait, so who is, which node is that?
That's the weird super linky one we're looking at.
Okay, so that is the candidate who I was talking about. That's my DA.
That's your DA? We found her?
She's running for the Attorney General. Yeah, that's her candidate committee right there.
I'm fucking good at my job, dude. All right. So let's run some of these stats. So there's a whole bunch of different stats you can run on the network, and it's all very fancy. And I'm not a mathematician or statistician or any of that. I'm a caveman who knows how to use Gephi. So the way that I know how to do it is that you can run, a lot of these will give us, basically when you run them, they'll add new fields to the node's data laboratory, right? So right now we only have one field in a node, and that's the ID, and then we have a blank label. And what we're going to do is we're going to add a bunch of new columns based on the network data. So average degree is the number of incoming and outgoing connections. So now we know in your network, every node has an average of 6.2 connections.
And we don't know the directionality on that, right?
I believe we do. I think you gave me a directional network.
Yeah, it was source and target for sure, but how do I read that? Oh, so is that
that's any connection.
6 targets?
That's yeah. Just 6 connection in or out, right?
All right.
And
so
then
before we do that, should I give you this CSV with the ID and a true false value for candidate?
Yeah, and while we're here, let's think of what other data we might want to bind in per candidate to be useful. Because this is the last time I'm going to load in. I'm going to just load it in again. You know what I mean? So let's make sure it has everything we need.
Throw in the name in there.
Yeah, throw the name in there. That's great.
You know what? Okay. Yeah.
Somebody's in the chat.
Hey, do you ever use that new sorry, is there someone in the chat?
Nope. I'm watching my own video.
Do you ever use that new operator, the conditional access or whatever it's called in JavaScript, question mark period, so you don't have to do...
No, that's crazy. How are you into that? That sounds fun.
I try and use it, but it always breaks it. So
Because nobody
good at
expects it. All right.
yeah. Okay, so if there's so let me quickly throw the name in there, and then should I throw the office and stuff in there while we're here, like the office and the district
Please.
number and the party? I'll just do all that. Why not, right? Okay, so
Does that make sense? Did that answer at least some of your questions about Gephi?
Yeah, I mean, it's cool, like, right? Because you already found like this one node, and now I'm like, and like, what's crazy is like this is a limited universe of the data, right? Like these are the committees I have decided to focus on because I know they're involved.
Right.
But like, there are random committees that get formed every day, way too many for me to just, pull in all the time. So, and so, hey, do I need a like a binary field for this candidacy, or like if I include like a field like candidate, and it's
I'm gonna make it
name or
categorical.
null.
I'm gonna color it categorically, so as long as they're different values, they're gonna get different colors. I don't really care.
So if they're all null, all the null ones will be colored in the null. I'm just gonna make okay, cool. So I got a new CSV, I got the ID, and I got all that other data in there. But But remember that a lot of that data is not going to be there for all the committees, right? So like, okay, district party. Cool. Cool. I just send you an observable notebook, but sometimes I have any big data computations, so I think it'll be fast.
Just send me the CSV, the node CSV.
Okay. Can I just drop it through this Google?
Oh, that'd be dope.
Not letting me. Cool. I text it to you.
Yeah. That works for me.
Okay.
Sit down and get serious. Get down to work.
All right, sent. So you should have a much better, more up to date, more detailed node CSV.
Okie dokie. So we'll call this EJ and Jeremiah make networks. Nodes with candidate.csv.
That's a new one, yeah.
Great. And let's add our edges that we downloaded way back when. At 7:50 p.m.
So, like, does Gephi have a concept of like a project that you should be like saving in your directories too, or?
Yes, but it's pretty wonky. So I like to have lots of versions of things generally.
Got it.
Like lots of versions. More than you should probably have.
Mm-hmm. I mean, how much of a bummer is it to miss data because you overrid it?
Or even worse is to show a client something and then you'll rerun the layout in Gephi and they'll be like, oh, I really like that layout you had last week. And you're like, well, it's gone forever. So I'm glad you liked it. You should have mentioned it at the time.
Looks like similar numbers. I don't recall.
Yeah, it looks exactly the same. So let's see if we can get our hairball on workspace 2. No, our hairball is on workspace 3. But if we look at a node, what does a node look like in our data lab? Great. is candidate. Look, and it makes it a Boolean, makes it a check mark because Gephi's so smart.
Nice.
So smart, made by geniuses. Great. I feel really good about this. So let's run all of our stats on it because that's going to be really dope. Why is it? Is workspace 3? It's weird. Workspace 2. Do they not have the same edges?
They should.
Like it should be because I'm getting two different. It opened two different. That works for me, right? It opened this one with 1823 nodes and 11335 edges, and this one with 1700 nodes and no edges. So I'm just gonna do. But the one with 1700 nodes and no edges is the one that has your candidate data in it.
Well, can we just add edges to this? I just don't think we added the edges one to that workspace.
All right, I'm into that. I'm into that idea. Let's do import spreadsheet. Edges, open. Import as edges table. Great. There is no time representation really. Edges merge sum. Append to existing. That's where I fucked up before.
Got it.
Love it.
Ooh.
All right, great. So we have nodes, and we have edges, and we have our beautiful hairball that we love so dearly. I'm not even going to untangle it. I'm going to make you look at it for a while we run our network analysis. So we're going to do average degree, 6.2 again. I'm glad that didn't change. Ooh, now for a fun
Wait,
part.
where did you do that again? Where do you run those stats?
So it's all in this right panel, this like stats panel.
Okay.
The thing that I'm most excited to do that we talked about when we talked about having this session is using the amount given as the weight.
Yes.
And so I'm going to do that, and you're going to love how we do this in Gephi.
Great.
So there's the copy data to another column button. And we're going to click it.
Okay.
We're going to click amount, and we're going to copy the data from amount to weight. And boom, all of our edges now have a weight equivalent to the dollar amount that was given. So now, if we go to our network, we can go. Let's look at edges, and then let's look at. I think is this size. We'll do ranking on weight, and I guess that's the color. Oh, I can do it. I have to do it in preview. All right. Pretend I didn't. All right. So we have our weight. So now we can do average weighted degree, which is 35,000. So that's your average connection.
Or total connection. Yeah, average connection. Right, exactly.
That's a crazy number.
That's interesting by itself.
I don't know if that's the right way to think about it, but yeah, we can look at it more. And then network diameter is like how many jumps. That doesn't really matter to me as much. Graph density.
Well, that could be interesting. Like that could be interesting if you're trying to track like the pledges I was talking about, right? Like if you're trying.
That gives you closeness and we can do and we'll normalize it. We can do that. All right. And then we can also do modularity. This is my favorite one because it basically separates it out into communities. You're there?
Yeah, but apparently our group call is going to end in 10 minutes.
How do I make it more? Do I just give it money?
I think we just.
Yeah, like ask me for my credit card. Hilarious. I'll just restart it. But
Yeah. Fuck you, Google.
Yeah, fuck you, Google. Modularity does communities basically, and the resolution determines how many communities you get. So like a lower resolution is more communities, and a higher resolution is less communities. So I'm just gonna run it at 1. My gut feeling is that we want like 5 communities. Between 5 and 10.
Community.
Like based on the network, it's like a segregation. Like these ones are, I don't know. I don't fucking know how modularity works, dude. It like makes them in little neighborhoods. It like really reliably splits them into little neighborhoods that like have similarities in your network that you can then intuit what the network saw usually.
Okay. Sounds promising.
So we want between like 5 and 10. So I'm running it, and we got 59, which is too many. That's too many communities. It's probably close to reality because there's a lot going on in California, but I don't want that much detail. So let's do a resolution of 2.0 real quick. And we get 50. No. Let's try 10.
You're trying to get to 5 communities?
I'm trying to get, yeah. And it looks like this network is...
So what are we learning from this being so hard? Like, you have to add a lot of resolution to get down to the communities. That means there's like lots of interconnectedness.
No, I mean, no. It's the opposite of that. It means that there are a lot of very disparate neighborhoods that you can't find communities in. There's a lot of that makes sense with your candidates, right? There's a lot of not a ton of interconnection between candidates, but we can try and find it. Let's try and do like 25 even. We're kind of pushing it up. 37 communities. I don't know how low I can get this. Let's see. What did I do? 25 last time? Do 50.
Yeah.
36. Let's do 100.
You got one down. Going from 37 to 36. I'd say go like 400 or something. Okay.
I mean, 36 might be the limit. We keep seeing it, right?
Yeah. Okay. Interesting.
Yeah, 35. All right, so let's look at what that actually means. So we can color it by partition. Let's use modularity class. Oh, most of them are in this one. See, this is the problem. We have one big community and then little tiny communities. Do you want me to run it real quick?
Yeah, do the layout so we can. I mean, that's cool, right? Like, basically, like, what that's telling me is so many of these are like fringe communities.
Yes.
For fundraising.
There's the big mainstream 5 community, which we can figure out what that is.
What does that number mean? That's just the number.
That's just if it could make up names, it would make up names, but all it's got is this. It can only speak numbers.
Got it.
I'm curious what this blue is.
Kind of. Yeah, me too. Is this the normal kind of distribution of modularity?
No, this is not right. So we just ran it on 200. Let's rerun it again at like 10 and see what we get back. Just see what that looks like. So we have 42 communities. It's still a huge, like it really is a huge main group and then a bunch of little offshoots.
Yep. Interesting. Wow.
This is 4 south 2. Yeah, right. You have your big main group and then a few subgroups. You should be. I mean, let's run it at. What did I run it at? 10. Let's run it at 1 and just see. Or did I just run it at 1? Yeah, I did.
No, I thought was it 1.
No, I must run it at like 5 or something. All right, so there's more. This is more. This is better, right? So now we split our community, our big one, into a few smaller ones. There's this orange one.
How'd you do that? We're just increased the resolution.
We're tuning our modularity resolution to seeing what it looks like. This is what I mean. Like this is the art of network. Like totally. This isn't written down. Just like fucking, I don't know. Use your intuition to like make it look in a way that makes sense. And anyway, I don't know.
Yeah.
It's a way that because
that red cluster.
Yes, exactly. Now I really want to know what that is. So that's 23. So we can go into filter, and now we can add filters to our network, where we can say where's modularity? If modularity class is 23, show it. Oh, fuck. Oh, that was it. There we go.
Cool.
So that's just this little world. And let's see. Is it going to be annoying on me? Sometimes it doesn't like to render for me.
Yeah.
But then I just fight back.
And you won.
and put it in whatever screen I want. There you go. That's wild.
So can you how do you zoom in this view and get deeper in that cluster?
It's there's 2 things I'm working with right now. There's the overview and then there's preview, and preview is kind of like your export. So now that we have the network shaped how we want in our preview, I'm going to the export to tune it and add labels. And right now everything is red, and I'm pretty sure that's because it's got huge links that are overlapping everything. So I'm just going to turn things off real quick. Right, so if we just show nodes, it renders okay. If we show the length...
Because we're doing it by weight.
Yeah, exactly. No, there we go. Okay, so I just had to turn it off and on. Classic. And then I have some... what are we going to label them with? That's the other thing. So we need to go into our data lab, in our nodes...
I mean, ID is probably that's the most
candidate. We're just gonna copy, same thing. We're gonna copy data, and it's gonna be candidate, which we're gonna copy to label, and now it can access that label, but they're very, very small. So let's make them bigger. Right now they're 12. Let's make them 36. Oh, but they're white. Color original. This isn't the real default. Because I have like my settings set up. Yeah, that makes sense.
Oh, now I see a label, but I also see all that.
Yeah, I'm gonna turn it off and on again and see if that helps. Yeah, it definitely has to do with the edges. Edge labels, node labels. There we go. Yeah, but then it resets my settings. What a good app. What an app.
Yeah. So one thing that's interesting that I still like, I just find Neo4j like kind of hard to use or get started with. I'm sure it's really fun once you understand it, but the syntax to me looks wild. But what seems cool about it is that it's like a graph database, so you can like query these kinds of connections. But I guess you can just take it into Gephi, and figure out those connections and probably export the data, right?
That's exactly right. So what we just generated now in our nodes column, all that data is here. So we have integrate. This is the stuff that you want to talk about before. I just want to take a look at this network. I just want to label it real quick, and then we can look at that a little bit more. I think it's because...
And is all that stuff that showed up in the data lab, is that also filtered down to this same red network modular?
No. This is just me trying to get something presentable that I can take a screenshot of real quick.
All right.
Because I think it's the Fox. Okay. There we go. And then we want outline size 1 to 100. All right, and this is where there's other algorithms you can use. So like, you see how they're all overlapping right now? We can just do prevent overlap. And then there's another really good one called label adjust, which we can run, which like spaces them out a little bit. I don't think that actually did anything. And then no overlap is good, right? It spreads them out a little bit. So now when we refresh, now they're at least spread out a tiny bit. Let me bring our font size down a little bit. You see what I mean about tuning?
Totally. I mean, this is the kind of tool it is, right? So.
So this is like our first little tiny network. Kind of mildly interesting. You could tell me what this is. Mike Stoker, Greg A. Hart, Mike Kerbasi. Anyway, that's what this little orange network is. So let's take that filter away and start. Let's size it. Let's start answering some questions, getting some insights. It's almost 8:30. Let's take our filter out. Let's run force atlas 2 a tiny bit. Oh, we can also, because we gave the edge weights, edges have weights equivalent to the money given, we can adjust how much the edge weight influences this network. And so right now it's at 1, but we can have the money have less influence on the shape of the network. Oh, God. I broke it. And it'll run random real quick and have it try again. Random layout. There. They're so tiny. All right, force atlas 2, run. There we go. So this is with edge weight of 1. What if I just do 1.1? Oh, it just flings it everywhere. Do you see what I mean? It's, oh, did my Google Hangout just end? That makes sense. New meeting. Start and end. You know how many times I've just like talked to myself and there's nobody on the other side of the video chat? Often. We do need a new link. Maybe I can fix this before he's back. There we go. Oh God. Only works at 1.0. Admit. What's up, dude? Sorry about that.
No worries. Did the stream die or did it just?
No, just a video chat, and then I talked to myself in silence for a while, so that was fun.
But you're not streaming anymore, just FYI.
Am I not?
Cannot see your wonderful Gephi creations.
Huh. Let's see. No, it's working for me, I think. I just checked it.
How come I can't see it?
Oh, because I'm not sharing my screen with you.
Yeah, right.
Yeah, I can fix that. Sorry about that. There's a lot of sharing. There's a lot of screen sharing going on right now.
Got it. Thank you.
All right. Apparently people are trying to post in the YouTube chat, but they can't. I think it's because I have some rule like you have to have a YouTube account or follow. I think you think you might have to follow me. All right. Anyway, we're having fun. So yeah. We generated a bunch of data about the nodes, and so the first thing I want to do is like answer some of your questions with the sizing of the nodes. So what was the first thing you wanted to know? Who was giving the most?
Right, so that would be the person who is the most often the source.
Right, so we want to know the out degree, right? The out degree measures how many times a node has an outbound connection.
Yeah, and as integrate would tell us who is receiving the most.
Exactly. So we're just going to do out degree first. Either one, whichever one you want to do first.
Out degree.
Out degree. All right, so then we do that, right? And now it works on the network again because now it has a lot more space to fill. Make this even bigger. We can make, so now I'm going to make the smaller nodes smaller and the bigger nodes just a little bit smaller. Turn stronger gravity off. Make my scaling a little bigger. It's such a compact network. It's kind of weird. I don't know.
Well, let's look at that weirdo. Like, let's look at the tail, I guess.
Well, I just want to make sure that this is running properly because it's being a little funky on me.
All right.
Like one thing you can do is a circular layout ordered by modularity, right? So now we have a circle split into neighborhoods. Oh boy. Right, this is where the circle comes into play because it just looks sick.
Yeah, that does look cool. I think with this network, it's a
little too much. So
I still kind of want to understand more about the modularity, I guess.
There we
the
go.
Modularity class.
I'm sure there's a fancy paper you can read.
I won't understand half of it, but then I'll learn one phrase that I'll Google.
See, I think it's because our edges. I know why. So you see how our network is kind of going crazy? Like everything like wants to be together in a way that it seems extraordinarily too much.
Yeah.
It's because our weights are in money scale, and I'm pretty sure it wants weight to be 0 to 1.
Oh, okay.
You know what I mean?
Sure.
So
let's see.
I don't really know how to do that.
I could do that. So what I'm going to do is I'm going to just make a D3 linear scale. I'm going to min-max that shit, and I'm just going to generate a value and send you another edge, I guess. Is that cool?
Yes. Yeah, and I'll just add to existing. That's the innovation we found out last time we did this.
Cool. So
I might also
yeah,
I want to take like a 5-minute break in a second also, because if we can get to a good spot.
Okay, sounds good. So I gotta go through and okay, right. So it's crazy how often I use D3 for not necessarily chart making. I realize this is chart making, but D3 is not going to be the.
No, it's mostly now that I'm using view a lot more, like I don't even do select enter append, like I just use D3 helpers basically, right?
Right. D3.max edges. And this has to be between 0 and 1, you say?
Yes, please.
Okay. Okay, so cool. I think I got it. Let me download this. Edges with scale. Cool. There you go. So that's interesting. So you do want to kind of like keep edges at weight somewhat proportional.
Yeah, I didn't even realize that. I've just never put in weights that large before, and I didn't understand why when I change edge weight influence, even to 0.1, it was breaking, and it's because it's like running just absurd numbers through the edge weight influence, if that makes sense.
Yeah.
So this is edges with scale. We're gonna open, import as edges, and we're going to append to existing.
Nice.
Edges merge is going to be last. That's this one that we're importing now. So if it sees duplicates, it uses this one. That's my understanding.
Got it. Okay.
Great. So let's look at our data lab. Scaled.
Yeah.
Great. So copy data scaled becomes our weight. Okay. So now let's try and do our Force Atlas 2 again. Oh, fuck. Let's see. Put everything in the middle again. Now run. It's being weird. Like this, it's not always really. I might just quit and try again in a second. But you see, like, so I do random layout, right? Which puts them all like randomly in the middle of the screen. Maybe my big nodes are too big for now. I'll just bring them down. All right, so I have my random layout.
That looks like the square layout, yeah.
I'm just going to run Force Atlas, the old one, which is really slow, but maybe that's better because then we can see what the fuck it's doing. So it's just like repelling, adjust by sizes, yes. It's so slow. This is why we use Force Atlas 2, except when I run it, it just fucking flings everything. Let's do speed 0.1 instead. Approximate repulsion. All right, now we're cooking with fire. All right, it's too big. Scaling's too big. So let's turn gravity to 1, gravity to 10. Okay, gravity to 20. All right, gravity to 50. Okay. This is starting to look like a network, my friend.
Cool.
So let's make our bigger nodes big again, because that was nice. Maybe even bigger. Yeah. And overlap. You see how slow it's going? It's because I told it to be slow.
Yeah.
Okay, so this is interesting. So let's just look at what this looks like. Right? It looks insane.
It does look insane.
Put it here. This app is so weird, dude.
I mean, I'm thankful you're teaching me because I feel like I spent an hour and a half just trying to get the weights to show up, and the answer is weight is a specific special column, and you just copy data to weight.
Yep. Yep.
So, yeah, quite an app.
We should get a chart showing up soon. There we go.
All right. Okay. Whoa, interesting.
I'm trying to zoom out, but it's like overwhelmed right now. It's a huge fucking network. All right, now out too much.
That's cool looking though. Look at that. A little swoop.
I'll take a little photo of it. And let's make our names.
I mean, what is
bigger.
your like instinct when you see a network like this? Like, what do you think?
It means we need to filter it down to look at its neighborhoods.
Okay, which are colors right now, right?
Yeah. So we have like a green neighborhood and we have a purple neighborhood. If I had to guess, purple's like more mainstream. Green might be challengers or Republicans or something. We also have this dark navy blue, which is like a mix of the two. These might be libertarians who like sometimes mix with sort of the green world. I don't know. This is all guess and hearsay, but just based on the network.
Yeah. You're totally just projecting onto the graph, but that's cool. I mean, that's how you start, right? You have a question.
Yeah, these are all PC. Like these are things I would investigate, right? Like I'm curious. Let me put it a different way, right? I'm curious why purple, right, is like outlier. Yeah, I mean it's not tight in the network, but it's like the main strain of person. I'm curious why the blue don't sit together. Like these are like this is like a third category. You know what I mean? There aren't very many of them, but they're pretty big, so they're pretty like well. You know what I mean? They're pretty big. I don't know. I'm curious what they are. So let's like the navy blue would be a big question. I'm curious like what this big green streak is. Like just reading the names. I don't know.
So is there a way to figure out like what makes them green? Like I know it's the modularity class, but is there a way to be like, I guess that's filtering by just that class, and then you just look at that cluster? Is that basically?
Yes.
Okay.
Yeah, and like
just so you know, like I don't see any clear partisan breakdown here.
Well, let's we have candidate, right? We can color by party, right?
We can, yeah, we do have party.
So we have nodes. We have color. Let's color by party. And let's make our Democrats blue. And let's make our Republicans a red. And let's make our green. They were already green. Incredible work. And null, we will make gray.
Make NPP is what we call independent in California. Make that like
they're like an orange.
Yellow. Okay, fine.
All right, so most is null. It looks like, you know what I mean. Most we don't.
Makes sense, right? Like most are not candidates giving; it's candidates receiving. Interesting. And so, like, if you click on one of those big yellow bulbs, then we can query what its ID is.
We can do that. We can also label them if we copy our shit over in the right order. So we have nodes. So what we're going to do is we're going to copy data. We're going to copy ID to label. And then they're all going to have labeled their ID. And then we're going to copy name. No, we're going to copy candidate to label. And only the ones with names. No, fuck. God damn it. Because it's blank. You see what I'm trying to do?
Yeah. Clever. Almost.
So close. But But then we would have the label would be the ID if it wasn't a candidate. You know what I mean?
Yes.
Hey man, why don't you go make your own labels and send me a Node CSV?
Yeah. So in that case, well, the problem is that but it would just be that ID or the candidate name, right?
Yeah, exactly. I just don't have in this application. I don't have the ability to do it.
Yeah, I get you.
Maybe I do. If I merge label and ID.
All right. Nodes is candidate parentheses 1.csv coming at you.
I think I got it.
Okay, cool.
I made a new column called label ID, which has the ID and the name together.
Nice. Okay.
Which might make this graph terrifically ugly. We'll see.
I mean, those IDs, as hard as they are to read when you're doing campaign finance analysis, you kind of need them around all.
Yeah, that's like what you need. That's like the thing we're looking at.
Yeah, it's like the foundational query block.
Yeah, we're gonna need at some point. We're gonna need to apply a filter that makes sense so that we can get
Ooh, look at those labels.
The problem is I'm trying. Like I have the preview pane in my overview, so it like renders it weird.
Yeah.
We need to make these much smaller.
Damn. And so, can you remind me what's the size of the label mean? Like, why would one of those names?
I'm pretty sure we did out degree, so it means that they're giving a lot.
Out mean you're giving a lot.
Yep.
Okay. Interesting.
Here we go.
So what we see here then, tell me if this is right. Like you see how some of these nodes have IDs and names, right? That means they're candidates. Also, they're not yellow. That means they're candidates.
Yep.
So from the size of the name, we can tell who is giving the most from their candidate committee because there's the out connections, right?
Exactly.
So like Blanca Rubio is giving more money to other committees than Buffy Wicks over up in the upper right.
Yep.
Right? And way more than some of these smaller names that I can barely even
read. Yep. Oh, that was right.
But like 831628, whatever that is, that's huge, right?
Yeah, I'm zooming out one more level so we can be sure about that. Yeah, a lot of these are here's a fun way to look at it, right? Is you can see the outbound connections, they're colored by who they go to. So 742855, like they have a nice purple spread. I mean,
yeah, interesting. Well, do you remember what that number was? Sorry, you read it. I didn't write it down.
I'm trying to zoom in. Let me see if I can move it over to it. So this is the step we're at now where we're investigating. I should just export a PDF. And it's way easier to go through this in preview than in this fucking application.
Got it.
So I'm going to go to my files and desktop that we made together. Call it exports. And we'll call this, it's so hard to remember what you did. It's out degree. Party.
Committee. I don't know.
No, I just want to remember the things. It's color. It's basically size, out degree, color, party, R1.
Yeah.
And then I think 8.3. Give me a fucking poster, dude. Give me a 24 by 24. Sometimes you have to tell Gephi you're not fucking around.
Yeah, give me the big shit. Damn. Okay. I mean, that's a cool looking little preview right there.
Right. So here's our huge graph. So now we can actually export a little. It was 742,855. And this is like, it's like spray of output. It's really interesting. It's like such a mix. Only a few are yellow. I guess it's a little more red than blue, but really interesting.
What's that? Around 8.5. So a lot of these are unions, which is super expected in a state like California, right? Where basically single party control and Democrats, like unions are going to do a lot.
Here's a little a Dem that's interesting. I don't know who this is. Steve Glazer.
So this dude is tiny, right?
Yeah, he's doing tiny stuff, but a lot of tiny stuff.
Well, no, he might be getting big contributions, but he's just not giving it.
No, he's not giving any. Nothing. Gives nothing.
Yeah, that makes sense. That dude's running for controller right now. So that other one you first found?
Tim Grayson, though, is a mover and shaker in terms of a candidate committee.
What I want to see, right, is I want to see like the internal party dynamics that through the fundraising. So like which people are giving the most to their, which I can do. Now that you've shown me this, I can just keep filtering it. But that big one you found originally, 742,855, that's a really big donor in California. That's Big Tooth. That's a dentist lobby.
Ooh. Love it. I'm trying to figure out who else here is really, like, if you were to ask me, like, who is, like, the most influential candidate committee in California politics, I would say on the Dems, it's Rubio Blanca, or Blanca Rubio, Luz Maria Rivas. On the Republicans, I would say James Gallagher and Vincent Fong.
Yeah, interesting.
And if you were to ask me the committees, like the non-affiliated committees, it's like 139, 2639, and the one we looked up, 742-855, 742-617, 744-058, 790-773. That one's really interesting. That's a weird mix.
790-773.
So this is all about givers, right? I'm going to run it on Integrate real quick.
Yeah. Now, we can do this a different share session, but my next kind of question would be, how do I have multiple flows? So like, for instance, let's say I show the Democratic Party. Oh, well, I guess I just do it in the same way, but you're showing both because you have both edges already, right?
Yeah, exactly.
Okay. And then you can just filter it. You can just say, show me. Can you filter the edges to say only the...
Only what?
I guess it's like, I was going to say the contributions, but like, yeah, well, it's only contributions. That doesn't make any sense.
Well, we can only look at edges, only contributions above a certain thing, right?
1423480. What is that? So that's getting a lot, right?
Yes. So let's look at in degree.
I'll bet you it's...
So I'm going to filter this time instead, right? So I'm going to say you have to have at least 80 connections incoming for me to show you, right? And that's going to cut off a lot of the riffraff that were clouding up our chart before.
Bye-bye.
So this is, we're not sizing properly. So you want a size by in degree. Great. Oh, God. It's interesting. It's mostly Dems. I guess that makes sense. It's fucking California, right?
Yes, yeah. Yeah. Who's that one way up at the top?
Tim Grayson.
Okay.
So I want to spread this out a tiny bit because they're like on top of each other.
So that's the only dude Steve Glazer gave to? Is that what I saw?
No, this is above, remember, above 80 outgoing. So let's maybe pull it back. Let's do above 50. So it's like a little, we didn't actually add a whole bunch just now, but here's what it looks like. A little busier.
Got it.
But within our filter, you know what I mean? And there's another one
Right,
that's
so these are only the highly connected people.
exactly,
Communities, right?
exactly. Do you want to look at the least connected people? You want to filter out all the highly connected people? Let's do. You have to have less. You have less than 100. What does that network look like? Less than 100 and more than 10.
Okay. So these are basically like mid-tier influencers.
Yeah,
right?
these are your mid-tier influencers right here.
Interesting. I mean, there's still some of the same characters we saw before, which makes sense.
Yeah, but
Like,
before I was pretty wide. Like, if we look at like just the killers, right? Like just the influencers, like say above 100, right? That's a pretty hard cutoff. And let me run. I mean, it's fine to be like this. Right, this is what the fucking real shit in California.
These people get tons of different connections.
Exactly. Right? Different connect, not just, and this isn't weighted, right? We're not even accounting for money at all. We're talking pure number of connections.
Right, it has nothing to do, but we already kind of controlled for that because the data I gave you wasn't every contribution, it was like aggregated by contributors. So we kind of controlled that already, but this is very interesting because this dude, Alex Lee, in the lower left corner, 1435518. This guy is widely considered to be on the left-hand side of the Democratic caucus. This big-ass line going to Anthony Rendon. Anthony Rendon is the Democratic leader in that chamber,
Interesting.
Institution, basically, the center.
So let's see if we can make this bigger. So we're sizing our links right now by the weight. So if I can accentuate that, right, you can have bigger connections the more money they gave to each other.
So there's a lot of money flowing between Anthony Rendon and Alex Lee. Is that basically the way I understand this?
That's exactly right.
Wow. And then Rob Bonta is really big. I mean, this is one of the premier races, so that's going to get a lot of money. It's statewide, attorney general, powerful position. And that's why his name is so big, right?
Mm-hmm.
But then I noticed there's only one yellow committee.
Yeah, what's up with that?
So,
it's Tony Thurmond.
Is that one won for? Okay, that doesn't really. I mean, that's just because that race is nonpartisan. It's like the top educator post, but he effectively is a Democrat, like teachers unions and stuff. It's just that race is nonpartisan, so that's kind of not something we should care about.
So let's open it back up a little bit, right? Now we're looking at just 100 to 200. Let's look at above 50 again with our new weighted style.
This is how you do your analysis. Basically, this is how you figure out where you want to go.
Yeah, exactly. Well, we just it gets really busy and complicated, and then it makes more sense. And you're like, all right, now I want to know a little more. This is now busy and complicated again. So I'm going to run the layout more at a bigger layout. Now it got really small. Let's turn gravity down to 1. Now we have a big layout. Now let's look what this looks like. Oof. It's a lot of Dems, but we got a little more fleshed out on Tony Thurmond, right? Tony's all in the midst of the Dems, you know what I mean? Ooh, what is going on here? Whatever this is fascinating. Sorry. This
is like actually like candidates giving each other candidates here. Because like basically I don't see any non-candidate nodes because they're all colored, right?
Yep, that's right.
So the most connected donors or the most connected actors, but this is in degree, right? Is that correct?
That's correct. They're receiving the most.
Okay. So of course it's going to be candidates. Got it. You do have a more fleshed out Republican network, don't you?
Okay, so let's do that next step, right? So we have a weighted degree, which I'm going to recalculate because I don't remember if we did that before we updated our numbers. Okay, we did. So now it's 0 because it's between 0 and 1 now. So let's size them by their weighted in degree, right? Which is the number of connections. I don't know how to explain it properly. It accounts for the weight in the in degree connections, right?
Some mixture of connections and amounts.
Okay, and these are too big now. So there's a much bigger differential. Does that make sense? There's a order of magnitude differential in size now. between candidates because the
right.
smallest ones are the connection. You can have there wasn't as big a difference between number of donations, and there's a huge difference between the size of donations. Does that make sense?
Right. Yeah, totally.
And now I can't even get the fucking nodes to show up because of how so we can do a spline. So this is like you can add a little graph to it. So does that make sense?
What does the graph show?
Like it retunes your weight. So we're doing weighted degree, but if it's 0.4, you can have it be less. So it's not linear the way it grows.
Cool.
So we can get our smaller ones to show up, maybe. You know what I mean?
Yeah, or the opposite, right? Like you might not care about the small ones.
Yeah, I'm trying to.
You just want to see who's the most connected or something.
Right, because if I do in degree like that, and then I do weighted in degree, or maybe just weighted degree. That's the incoming and outgoing together. Let's do that. It still doesn't show up for me, though. It's weird. What does it look like in the preview? Yeah, it's like all the edges and no nodes.
I mean, I do see
the number might be very small. Like, it might just be really small. Oh, yeah, okay, it was. Okay.
I guess it is small, right? I just saw that the average is 0.0.
Yeah, exactly. So I did 10,000. Let's do 5,000. And they're all pretty similar. It might be because of the way we rounded you know what I mean? Like we lost some resolution getting it between 0 and 1. But they're all pretty similar in size, right? Let me take my filter off, right?
I mean, I guess that makes sense. Like, you know, races, like there is some variability in the cost, but like, you know, there's kind of like a market dynamics too, right? Where if a race is super cheap, then it will attract a lot of attention and its prices will go, it'll cost more to start running there because it'll be more competitive. Yeah, if you can win an election for like $5,000, of course everyone's going to try and put $5,000 in that election, right?
That makes sense. It's so hard to understand like what, because I don't know this data set similar, you know, as well as you do, of like what pieces will be useful and what won't. So I'm kind of just like poking around. But is there?
You've already shown me how to start the analysis I want to do, and then like what I would probably do is start going more. I would start grouping by modularities, classes, so I get a sense of those neighborhoods. Because basically, what would be really cool is if you could put those neighborhoods in words, right? If you could describe like what is the linkage in that neighborhood. And that by itself is kind of interesting because this kind of shows the partisan flavor of the money, right?
Yeah.
That circle chart.
That's what I'm saying. I like this circle chart sometimes to show like when you have small groupings. I'm going to try and zoom out so it's useful. This is not useful to anybody.
Yeah, I mean, it was already interesting to see on that last one you were doing, like the Republicans were off on the upper right, and they were like in their own network, and that kind of makes sense. Oh, well, that's pretty cool.
It's just trying to say. I'm going to try and save it in a second. I just want to make sure it all displays right. There we go. Yeah, that's cool. See, this is cool. Whatever the fuck this is cool.
Mm-hmm. It is, yeah. I mean,
this is California politics right here, bro. It's a whole wash of blue. For real, right? Like this is.
Yeah, I mean, I think you should change the yellow. I think it's getting washed.
Yeah, I agree. The yellow is kind of whack. How do we fix that color? Make it like what? Like
I don't know.
Black. It's like a dark gray.
Yeah, sure. Yeah, I mean, wow. And I was trying to look over there. I'm sure there's like some sort of opacity on that edge you can do too, right? So
yeah, let's do. Yeah, so
blends a little more nicely.
Yeah, let's do 60, and then we can make them end up a little bigger. So we'll have it max be 72 and the minimum be 0.5. And I'm going to save that. And what is this? This is circle. I believe this is in degree party. Yeah, dude.
I mean, that is interesting. So, wait, these lines, so like, just where are these red lines going? We don't know that because those are nodes that don't have.
No, they have, I mean, we can see the big ones, right?
Oh, yeah, you just gotta go deep to see them because they're not receiving lots of money, and we scaled it by in connection,
Yep,
right?
exactly. But like this one does go to like 850,288, right? And 78221, a bunch of these Republican ones. 782,149. Sorry, 850,288.
Yeah, so that's the California Business Properties PAC, which, yes, I can imagine that being a more Republican donor. Than,
What about 782,143? I'm gonna tweet some of this stuff out.
That is the engineering PAC. But they've got a lot of cash, it looks like. And so you're saying they mostly made donations to Republicans.
Yes. That's what I believe.
Or at least they give to both. Yeah. Interesting. I mean, they give a lot. Like, here, I'm going to send you this. So check out what we're dealing with here. Like, this is the nature of the beast. Cheap way to get subscribers, EJ.
It's really to keep the trolls away.
No, yeah, for sure. Fair enough.
It's less about getting the subscribers and more about keeping the trolls away. But I can see how. I mean, it's a little of both. Let's be real.
Yeah. So I dropped a link if you want to pull it up in the chat just to close out on that one.
Yeah, for sure.
You can start to see, so this link is all the contributions that the engineering pack has made.
This is wild.
So you can just see, it's just constant. Like, it's just a constant drip of money.
Do you think they do that so they get noticed? Do you know what I mean? Like, it's probably like you probably get more bang for your buck if like they see your name every month than like one big one, right?
I've often wondered that because like sometimes you'll see a pack that gets a lot of money on the same day, and it seems to be you can just understand some of the nature of the pack from the dates. I don't have a good insight into how it works yet, but like, it's disturbing because this is how people get meetings with legislators, right? Or at least how they get their legislators to care more about whatever they want to care about. And so like, this is just spreading the influence around. Like, I've had like kind of like a non-piece that I wanted to do for a while, which is like, who hasn't PG&E donated to? You know, like
I like that. That's really interesting. I like that.
Yeah, more interesting list than like who they have donated to. Perhaps it's like a little longer, so it's not like a classic case like they don't give to two people. You know, I can't say something like that, but yeah, so you can start to see that this data is weird. What does it mean to give $4,700?
Well, see, now I want to go into the data lab and just like look at our top 10s, right? So we did all those stats. So the one thing I do is I'm going to export this data. You can do it yourself, but just so we don't lose it, I'm going to export our graph data with all the like weighted in degree, out degree, all that stuff as JSON. And this will be useful later too, because then we can make a cool like D3 force layout out of it. And we'll call this California Campaign Finance R1.json. And I'll do a CSV as well. Save as. Can I do CSV? No. Export.
But then it's in JSON, right? So at least then I could like.
I like having it in JSON because then we can load it into a bunch of other cool shit later, which will be fun.
Yeah.
So now that's saved, I just want to sort by like, let's sort by weighted in degree, right? Like that's who's getting the most connections. It's a bunch of like the first 10 are not candidates, and then you have Richard Bloom, David Campos. These all make sense.
Well, my hypothesis, I haven't memorized this. I probably shouldn't say this till I look it up, but my bet would be that first one is like a political party. But let's look. 142 3480.
Yeah, so this one had 2 donations, and they have like.
Oh, okay.
Just an insane amount. So what's
it made too large? They've given large.
They've received too large and haven't given anything. In our data.
So that, yeah, I mean, here's the link for that. You're right. Like, it doesn't look like they made any contributions.
But they, according to what I'm looking at, have received the most money of any committee in your data.
Well, yep. Okay, interesting. I mean, I see like a bunch of big. I see just $9 million and just 2 contributions I'm looking at.
That's exactly what I see.
Yeah, I can see how they would get that. Interesting. So that's actually not a political party. That is this one of these IE committees. Get this. The name is Californians to Protect Patients and Contain Healthcare Costs, a coalition of physicians, dentists, and healthcare insurers and providers.
What the fuck is that?
This is like par for the course in California. There was one that I was looking at this past week. It was a thing exclusively sponsored by PG&E during a vote a couple of years ago where they were voting to allow like publicly owned utilities. PG&E obviously not down with that, right? So PG&E created a committee, and it was called like Californians Protecting the Right to Vote, because like it was about voting for.
That's like it must be its own whole art, like naming your weird committee.
And then they change it too, right? So like a lot of these vehicles just kind of get shuffled around. They're like basically like these weird bank accounts. Very weird.
Can you send me or remind me or send me the name of that committee? I'm trying to tweet it out.
Oh yeah. Oh boy, I've got it right here.
Oh hey, what's up? Nick's in the chat, hanging out.
Just sent it to you. Not gonna make you write it down.
I deeply appreciate that. Sweet. And then let's just sort by a few other things, and then we can. I'm happy to answer any other questions that you have. But I feel like we're in a good place of like now it's just the fun part. Like now I just want to dork out on it.
I want to like go do it all and like take notes and then like.
So let's do one that's really cool that you can only do in Gephi, right? Or not? You can do it in other places, but it's really easy in Gephi. And let's do Eigenvector centrality. And so this is some fucking genius. Had some cool shit. This is how you find influencers. And so. A lot of times you can do this in like a Twitter network. This will be a person who's like retweeting other people. I'm really curious who your influencers are in this data, right? Like, and it's not about who's giving or receiving the most. It's about who sits between people giving and receiving the most. Does that make sense?
Yeah, nice, interesting.
So I think we have eccentricity. It doesn't look. Where's my eigenvector number? Eigenvector centrality, run. Do it. Great. And then let's get, all right, so if I look at my nodes, of course, the one thing I just talked up is not going to work. So I have between this, I have in degree, edges. Oh, I think I can size them by it, though. So we size them by the eigen. There we go. Oh, God.
Is it a circle layout, like just a really fast one, so it's easy to program?
Yeah, and I'm going to put it back once I get these sizes right, I think. And I think we can also filter for an eigenvector centrality above something. Remove attributes. This is a range filter on eigenvector centrality. I turn it on and I say it has to have a centrality above, let's say 0.146. Right? Because it's a fucking art. Right? So now we made a little influencer network. And let's see who's in it. Interesting. Very interesting. Let's get them to not overlap a little bit. Oh, and we can also, sorry, the other really handy Gephi tip I have is that there's two layout types. One's called expansion, and it just scales your layout up. And I use this one all the time once I have something that I like and the labels are overlapping. You just hit expansion a few times, and then you get like something that makes a little bit more sense.
Nice.
That's my hot Gephi tip. So these are your influencers, which are different, again, different from who's receiving and giving the most money. These are people who sit between people.
That's interesting. And you know, like this is basically a snapshot in time, right? Like,
yes.
This is like, so it'd be interesting to some of these people I've run before to somehow figure out a way to compare them to their previous self. Like Tony Thurman in the middle there, right? That's weird because that race is not competitive. He's basically running unopposed, but people are spending teachers unions basically are spending like this dude is about to lose. And I think that's maybe why he's an influencer here. He's getting a lot of contributions, which is kind of one thing I got to think about and figure out how to control for, because you can imagine that a rich person or a company could start 7 packs and give little bits through each, right?
Right.
And then that would affect this measure of influencerness.
Yes.
Right? Because if you have a bunch of committees, because like that's why.
Well, no, not necessarily. So it would account for that. So unless those committees were touching other candidates, they wouldn't necessarily, right? Because a lot of people touching one, if he's not spanning the gap for other people, then it doesn't count as influence. You know what I mean?
Okay. Wow. And so, what does it mean when someone is at the end of a node here? So, like Mark Levine on the right hand corner.
Yeah.
It's like, you know, as opposed to Alex Lee or Rob Otto, who's like in the middle of stuff.
Well, so it means they have a lot of connections within the network we've filtered down to, right? So we're only showing things above a certain eigenvector centrality. If I take that filter off, we can sort of see the world that exists behind that filter a little bit, if that makes sense.
Yeah. Interesting. It's one of the big challenges with this kind of analysis for this kind of data, because you end up coming up with all these filters to get rid of noise, right? Because there's just so much.
Yep.
And then you're like, but am I missing stuff in that filter? Because it's still, you know, either a weird contribution or whatever it might be. So it is kind of, it is an art in that way.
Well, it's like photography, and I really, and all data viz is like this. As a photographer, you go out into the field, you choose your lens. Is it a zoom lens? Is it a wide angle lens? You choose how much light to allow in. Do you see the shadows? Do you see the brights, right? Will you point your camera in an angle to either show one thing or not show another, right? And it's all reality, you know what I mean? But like you have a lot of input on and I think it's the same amount of input in this type of data viz, right? Like you point your camera, you zoom in and out, and all of that stuff, it's about being honest in those processes, right? And I think a lot of people, like, it makes their stomach churn to make decisions like that, but I think that's part of what we do. Like, that's what a good photographer does. That's what a good data visualizer does, right? Is make those choices and try to make them as honestly as possible.
Yeah, definitely. And like, you know, just talk about the ones you make, so you're not hiding
That's the other thing. Yeah, exactly. I made this choice, and here's why I think it was a good. You could have made this other choice and done that. I tried to do that with my CCRB blog post, right? Where I was like, here's literally every choice I made along the way. Like, if you think that I should have done this differently, especially with like NYPD data, right? Where people have really strong opinions about it and about what is good and not good analysis. Like, I wanted to be upfront about like, if you want to do this a different way with a different assumption, like you can get all the way to here and then take the fork in the road and do what you want to do. You know what I mean?
Totally, yeah. Sick, dude. Thanks for this. This was super helpful.
Of course.
It's kind of like that situation where you set me up with a tool and now I gotta like go play the tool a bunch. And then also the idea that it can become JSON with the stats in it. Like,
yep.
It, you know,
not only, so there's also a really cool library called 3D Force Graph. And the data that we just exported, it loads directly into this, and it is a 3JS powered 3D visualization that works in AR. So you can get like basically for free, and I did this with the NYPD data, you get this really cool explorable 3D version, which is kind of fun to play with.
That is cool. I love that, because I can also imagine that it works in Observable, so I can just like boom, boom, boom.
Exactly.
Yeah. Nice. Thanks,
cool,
dude. I mean, let me come back to you in like a couple weeks with like more sophisticated.
Listen, come any data set like this that like that was a lot of fun. It's really cool to make circles that mean things. You know what I mean, with real data. So any excuse to do it, I'm down for. Thank you for taking the time and hanging out and all that.
Sure thing, man.
All right, dude. So, all right, I'm gonna wrap up the stream. Thanks, Jeremiah. Thanks, Tony, Nick. Everybody hanging out. Appreciate all of you. Have a good night. Remember to explore data. Do good, right? Don't drive too fast.
Yeah. And make sure your Secretary of State is publishing good data.
Yeah, that's a good setup. Make sure your Secretary of State is publishing